Welcome to this video presentation. My name is Nasser Almadi and today I'm presenting a paper titled From Novice to Expert, Analysis of Token Level Effects in a Longitudinal Eye Tracking Study. This paper is co-authored by Cole Peterson, Farida Sharif, and Jonathan Miletic. Starting with a quick background on eye movement during reading, fixations are periods of time where the eye stays stationary over a word or a token, and saccades are jumps between fixations. The word length effect refers to the difference in reading time in relation to word length, as long words in number of characters take longer fixation durations. The word frequency effect refers to the difference in reaction time between high and low frequency words, where high frequency words are fixated for shorter durations. For natural language, word frequency information exists in lexical databases similar to the SILEX database, but for source code no such databases exist. Natural language research has concluded that linguistic factors such as word frequency and length influence information processing and eye movement during reading. An informal demonstration of these effects can be seen in the following example. You can pause the video if you need more time. The answer, of course, is the repeated the. This is a high frequency token, short, predictable, and after a return sweep, which makes it very likely to be skipped by the eyes. We hypothesized that similar effects should exist in reading source code. In this example, a Java programmer should be able to predict the I++ at the end of this expression. The presence or absence of these effects in reading source code could help us build better models for eye movement control, estimate typical reading time, the assessment of programming proficiency, reading difficulty estimation, and measuring the efficacy of different encoding styles. At the same time, we cannot automatically extend the results from natural language research to source code as they differ in purpose, syntax, semantics, and viewing strategy. To study these effects in source code, we use an existing eye movement dataset of 14 novice Java programmers and 6 experts. The novices were recorded after each learning module with 6 modules in total. The experts, who had a programming experience between 5 and 28 years, were recorded only once. The experiment material consisted of Java programs between 4 and 28 lines of code. We calculate frequency information by processing 10 successful Java projects with approximately 3.9 million lines of code, resulting in approximately 14.3 million tokens after removing comments from code. The frequency effect would appear as a reduced fixation duration over high frequency tokens in comparison to low frequency tokens. Since token length might influence fixation duration, it's important to normalize fixation duration by length when we calculate the frequency effect. Normalization by length can be done in 2 ways. First, division by dividing fixation duration by the number of characters in a token. The second way is by matching, which is done by finding high and low frequency tokens with the same number of characters. To search for evidence of the frequency effect, we start with the eye movement of experts. Looking at the mean duration for 42 high-frequency tokens and 36 low-frequency tokens that were matched by 6 characters in length, we find that both gaze duration and total time show shorter fixation duration for high-frequency tokens, yet only total time was statistically significant. Similarly, for novices, looking at 186 high-frequency tokens and 42 low-frequency tokens that were matched with 6 characters in length, we find a statistically significant difference or advantage for high-frequency tokens in gaze duration and total time. When we normalize tokens by division, we are able to include a higher number of tokens, resulting in statistically significant advantage for high-frequency tokens in all metrics. Now that we have some evidence of the frequency effect in reading source code, we can ask, when do novices acquire the frequency effect? To answer this question, we calculate the influence of the frequency effect on eye movement of novices longitudinally over the duration of a Java course consisting of 6 learning modules. Plotting the difference between high frequency and low frequency tokens in the 6 modules shows a positive trend between Module 1 and Module 6, suggesting an increase in the frequency effect over time. Moving to the length effect, looking at the eye movement of experts, we find that gaze duration and total time appear to increase with the increase in number of characters, yet this change was not statistically significant. The same pattern was statistically significant in the eye movement of novices, suggesting that token length influences eye movement during reading source code. Moving to the distinction between novices and experts based on their eye movement, we found statistically significant differences between the eye movement of novices and experts. These differences suggest that experts make shorter fixations on average, experts are more likely to skip tokens, and experts are less likely to refixate on the same token. We demonstrate an application of these results by building a machine learning model for the distinction between novices and experts based on eye movement. We use the same data and metrics described earlier, and we split our dataset into 70% training set and 30% testing set. And we apply a random forest model with tenfold cross-validation. This demonstration yielded an accuracy of 72.3%, with a precision score of 77%, recall score of 75.4%, and F1 score of 76.2%. Our first point of discussion is, why are there frequency and length effect in reading source code? A possible answer is that the length effect is a result of visual processing, where a longer word requires more time for encoding a more complex visual stimulus. As for the frequency effect, which influences lexical access, where stimuli that is more frequent is retrieved faster, this is possibly a result of the brain forming more synapses between neurons that are frequently activated together. Furthermore, the presence of the frequency effect in reading source code means that exposure to consistent coding style facilitates reading and ultimately comprehension. When programming language elements are presented consistently, their frequency increases, and thus, they become more predictable to the reader. Simultaneously, the presence of the word frequency effect shows that longer identifier names take longer to process. Therefore, shorter identifier names are potentially easier and faster to read, without sacrificing a meaningful name. In the context of coding best practices, our results seem to uncover the cognitive basis for good coding style. Finally, our intention behind the classification between novices and experts based on their eye movement is to demonstrate a potential practical use for our work. We envision an integrated development environment that is able to detect the expertise of a programmer and adjust its environment and recommendations accordingly. Thanks for watching this video. Names are...
Hi, so let's start with some questions. I don't see any question in the chat, so I will ask by myself. So what I want to ask to you is that if you find any difference between the 40 participants in your study that did not have any in programming. Did you find any differences, similarity?
Oh, so I guess the question is about the 20 participants, differences between novices and experts?
Yes, yes.
So yeah, we found some differences between them, and these differences are basically related to high likelihood of skipping for experts, which is similar in natural language. And in addition, the fixation durations are prolonged for novices, so they spend more time on tokens than experts.
Thank you. We have a question from the audience. So, do you think programming language constructs will have an effect on code comprehension?
Question, and we don't know the answer for it 100%. I think that's one of the good studies that can be done in the future and have been done a little bit before. But in previous research, I can highlight one paper that focused on something that relates to coding style, like underscore or camel case, and the differences between them. So Professor Benita wrote a paper on that topic, which is a good source if anybody's interested in redoing this work.
Thanks. So we have another question. So from Venera. So thanks for the presentation. Very cool work, indeed. I agree. So the first question is: do you think that abstracting knowledge would help here? And indeed, she reported an example. Nasser, do you think that abstracting knowledge would help here? Oh, Nazar, I think that.
I think maybe we just lost him. Yeah, it's hard to say. I don't know. For the first question, I'm not quite clear what that is. Did you split the data based on participant? Data from one user can be either in the training or testing set. No, we didn't do any sort of analysis like that.
Okay, maybe what you can do, you can answer on the chat because time is end. So time for the next paper. Thank you.
Bye-bye.